Dear students, today we will discuss on the topic about Kirchhoff's laws, Kirchhoff's current law and voltage law, and also we'll see some of the important terms related to electrical networks, that is nodes, branches, and loops. In the previous class, we have discussed about the energy, passive elements, and Ohm's law, and what are the limitations of Ohm's law. Today, we'll concentrate on Kirchhoff's laws. So, by the end of the session, we should be able to state Kirchhoff's voltage law and Kirchhoff's current law and able to determine the branch currents and voltage of simple DC circuits. Yeah, coming to network terminology, electrical network it consists of the interconnection of various elements like resistor, inductor, capacitor, voltage source, current source, battery. These can be interconnected. Interconnection of all these forms an electrical network or a electrical circuit. That circuit is said to be as linear circuit if all the elements of the circuit are linear elements. That means they do not change with the direction of current or voltage. The relation between voltage or current remains same. Also, the value of the parameter remains the same for changes in currents. Nonlinear circuit are those who change their values with a change in current. So they have different behavior for different voltages or currents. Bilateral circuit. Bilateral circuit is one where the elements in the circuit carry the current in both the directions and their behavior is same. Their properties will not change depending on the direction of the current. For example, we have resistor. The resistor value is 10 ohms, whether the current flows from left to right or right to left, like that. Active element. Active element is one which supplies electrical energy to the circuit. Passive element, on the other side, absorbs current or voltage or power. So, therefore, active element examples are voltage source, current source, battery, like this. Passive elements are those which receive electrical energy or absorb electrical energy, like resistor, inductor, capacitor. Then node. Node means it is the junction or the point at which two or more elements are tied together. Junction. It is a junction is a point at which three or more elements are connected at that point. Branch. Branch is nothing but the elements present in between two nodes or between two junction points. That connection between the two branches can be with a single element or can be number of elements connected between those two nodes. Next we have loop. Loop is the closed path of a network. When you start from a one point, pass through all the elements and again come to the original starting point, then it is called as a loop. The similar when we have what is called as mesh. A mesh is more elementary form of loop and cannot be further divided into other loops. So you can have a closed path. Within that, another closed path can be there. That inner closed path is called as the mesh, and the outer closed path can be called as a loop. So the parameters are nothing but circuit elements like resistor, inductor, and capacitors. Then unilateral circuit. Unilateral circuit is one whose properties change with the direction of operation. Active and passive network. If the circuit or the network has is having the active elements, then it is called as active network. If the network contains only passive elements, then it is called as passive network. Yeah. So with that basics of the networks, now we shall see what is the Kirchhoff current law and Kirchhoff voltage law. Kirchhoff is the scientist name. His full name is Gustav Robert Kirchhoff, a German physicist in 1845. He has derived the generalized equations which describe the current flow. Okay, current flow in an electrical conductor in three dimensions. So it was found that it is extension of Ohm's law because Ohm's law basically gives the relation between voltage and current. This is a common or fundamental relation. But in above that one, how I can use Ohm's law to make the calculations of currents and voltages of a branch or a loop or a mesh. That's the Kirchhoff's laws. So there are two Kirchhoff's laws. One is Kirchhoff current law and Kirchhoff voltage law. Kirchhoff current law and Kirchhoff voltage law, shortly called as KCL KVL. So let us first see Kirchhoff current law. So it is based on the law of conservation of charge. That means charge that flows into a point or a circuit will be the same amount of charge flows out of that point or a junction. In any electrical network, the algebraic sum of currents meeting at a point or junction is zero. If, for example, we have a junction called A at which many different elements are connected. Let us say currents through these elements are I1, I2, I3, I4, I5. Observing carefully, what is that we can find is like I1 is the current entering into A. It is called as incoming current. I2 is going out of A. It is called as outgoing current. I3 outgoing. I4 incoming. I5 outgoing. So there are some incoming currents to A. There are some outgoing currents of node A or junction A. Now let us take like this. Current that are entering into node are positive. Current that are coming out of the node are negative. Incoming current negative. Incoming current positive. Outgoing current negative. If we define like that, what is that I can write? I1 minus I2 minus I3 plus I4 minus I5 is equal to 0. So now rearranging, I can write this as I1 plus uh, I1 plus I3 plus I4. I1 plus I3 plus I4. What are they? These are all incoming currents. I1 plus I3 plus I4 is equal to the outgoing currents. I2 plus I5. I2 plus I5. So like this, we can write the algebraic sum or the total value of current at any junction. See, there are some currents entering, there are some currents leaving, but no current will be available at node A. There at that point it is zero. It means whatever the current that is coming in is going out. That's all. It is not stopping or storing at point A. Now, Kirchhoff voltage law. We have seen that the Kirchhoff current law is applied at a junction or node of a given circuit. Then what about Kirchhoff voltage law? Kirchhoff voltage law is based on law of conservation of energy. Okay, law of conservation of energy. So for this, you should have a mesh or a closed path of a circuit. If you take the voltages across all the elements of a mesh or a loop, the total voltage will be zero. This is because as you move from, let us say, point A to B to C to D and again back to A, if I move one round, again reaching the starting point, and consider the voltages of all the elements that are there, all the elements that are there in the path. So what is the voltage across this star? What is the voltage across this star? Like that, if you see, the current is flowing like this from A to A. So if the current is flowing from A to B, then the A is positive, B is negative for this R. So therefore current is a voltage drop now. That voltage drop is VAB. Similarly, current is flowing here. Voltage drop VBC. Voltage drop VCD. Voltage drop VDA. So you have VAB plus VBC plus VDC. Sorry, plus VCD plus VDA. If you add all those, it will go. It will get zero because you have started at point A, which is at some potential, travel to B to C to D to again A you are coming. That means when you again come back to the original junction or the point, it means that the potential difference is zero. Potential difference is zero. Or voltage between point A and point A is zero. So, dear students, today we have discussed the concept of what is a node, what is a junction, what is a branch, then loop, mesh, and different network elements. Then we have seen the important topic, Kirchhoff's laws, where there are two losses. One is called as Kirchhoff's current law, shortly called as KCL, and another one is Kirchhoff voltage law. Okay, so you have Kirchhoff's current law and Kirchhoff voltage law. Kirchhoff current law is applied at a junction. Let us say I have a resistor, I have one more resistor here, I have another resistor here. So at this junction, what is the current that is available is found using the Kirchhoff current law. And in case of Kirchhoff voltage law, there may be a closed path. There may be a closed path. Then voltages of all these elements, if I add, taking into polarity into consideration, the algebraic sum of voltages of all the elements around a closed path or a mesh is zero. So let us see example there. So find I and VAB for the network shown in figure. So find I, where is the current I? This one. You should find this current. And VAB. So this is point A, so 60 amperes. So this is A, and where is B? Yeah, this is B. So from year to year, you have to find the voltage. Normally, it will be voltage drop from A to B, or B to A, it is voltage rise. So you can see here now, let us take voltage drop negative, voltage rise positive. So when I move from A to this point, then what is happening? Current has to flow like this, but current is flowing upwards. So therefore, it is voltage rise. So I can take positive VAB. Okay, B is there already, VAC. Now between C and D, current is flowing like this. So that is also voltage drop, and hence you can see here this current, whatever is there at this junction, what I can write KCL equation. If let us say this is I1, so I1 plus I is equal to 1 amperes. I1 plus I is equal to 1 amperes. These two are outgoing, and 1 ampere is incoming. So now for that we can solve for the current I1. Next we have what I1 is coming to B, and the it is also connected to 5 ohms and 12 volts. So there is no change here. So what is that we have to find now? To find the current I and VAB. So here we have found I1, which is nothing but this minus 1 amperes. So that I1 is flowing here. The 6 amperes will also add, and there will be additional current flowing here. And this current passing through has the lost terminals, and hence if 1 ampere is going out, the remaining amperes will come to this 4 ohms resistance. Similarly, you can also make an attempt to calculate the current in this electric circuit. So answer is 1.7 amperes. You can go through. So having completed the discussion on Kirchhoff's laws, students should know to be now the student should be able to state Kirchhoff's laws, that is Kirchhoff's current law and Kirchhoff voltage law, and determine the branch currents and voltages of simple DC circuits. So, dear students, you can refer textbook K. Umarov, Basic Electrical Engineering, and for the today's topics, you refer chapter 1, 1.4, 1.5.1, and 1.5.2. So, dear students, please go through this course video repeatedly, and be ready for attending the class for discussion. Okay, thank you, students.